Today we're going to start finding out how to create or discover a line of fit with the TI-84. Okay? And we've done it algebraically. This is going to be much easier. I'm going to try to give you some keystrokes for the graphing calculator that will get you there. And so as far as what to write down, okay, one of the main things we're going to be writing down is the keystrokes. But first, I gave you this set of data for how the number of woodpeckers have grown since 1990 in a state park in Mississippi. The first thing I want you to find, okay, we're going to use this to, number one, make a scatter plot. We're going to do all of this with the graphing calculator. We're going to make a scatter plot with the graphing calculator. Then we're going to use the TI-84 to find the line of best fit. Okay, we're going to use that to find the line of best fit. We're going to graph that line and see if it fits. And then we're going to make a prediction. We're going to find out that this line of fit is a great way to look at trends and what's going to happen in the future. Okay? So, you see this set of data. The first thing we have to do is put the data into the graphing calculator. So, our first keystroke, okay, first thing we have to do is enter data. Okay, and let's write that down in our notes. We want to enter data first. And to do that, the first button that I push, and I walk through this with you, on the graphing calculator is the Stat button. And right after that, we're going to select Edit. Okay, so I'll go to the graphing calculator, and I'm going to press the Stat button. And you'll see at the top that there's these different menus, Calc and Tests and so on. We just need to stay under Edit and press the Enter button. And we'll come to our blank screens for List 1 and List 2. Okay? So your next step is then to enter our data. And 9 times out of 10, we're going to make our x's be L1 and our y's be L2 most of the time. All right? Now, on this list, what we're going to do is if I look at my data set here about how the number of woodpeckers have grown, we're going to call the year my X, or my L1, and I'm calling the number of birds the Y, or the L2. Okay, so we need to enter all of these. And one other thing, anytime they give you years, we're not going to enter 1992. Okay, this said this has been going on since 1990. So how many years has it been from 1990 to 1992? 2. So on the graphing calculator, we're going to enter a 2 here. For 1993, we're going to enter a 3 here. We'll enter a 4 there, and so on. So let's enter my data. The first year we said was 1992, so I'm going to push a 2 and press Enter. Now, it's easier to enter all the x's at once. So I'm just going to go straight down. 2 was for 1992, 3 was for 1993, and so on. And I'm just going to keep going down. Oops, made a mistake there. That one's 5. Nope, I left off 4, didn't I? 1994, 1995, there we go. 6, 7, 8, 9, and 2000, the year 2000 would be the 10th year. Don't forget to press enter after each one or it's not in there. Once we get the years in, then I need to match up the number of woodpeckers for each year. So for 1992, this is all from that table I gave you. We said there were 22. So you press 22 and press enter. Then you press 24 and enter. Then 27, enter. Then 27 again. Then 34, 40, 42, 45, and 51. We get our data in, okay? Make sure that there is a matchup. Make sure that every X value has a Y value matched with it, or it's going to give you an error, all right? So, let's go back to where we're kind of writing ourselves some notes. We have entered the data, okay? The next thing we're going to do is we're going to look at our scatter plot. Okay? And we need to make sure that our plot is turned on. So your first keystroke is second, then y equals. This is where we're going to make sure the plot must be on. Okay, the plot is on. Okay, so here's how we do that. Press the second button, then y equals, and it comes to this screen. Now yours may say on or it may say off, but let's make sure on plot 1, let's press the enter button, and you're going to see this screen. Make sure that the on is selected, because if it's not, it won't do it. All right? So we have selected the on. You'll see some other things here about what type of graph we can select. We want the one that's there, which is a scatter plot. You'll notice that X list is matched up with L1 and Y list is matched up with L2. And then down here, that's the kind of marks we'll use for my scatter plot. All right? So once we get that done, we can look at the scatter plot. So let's add a couple of keystrokes. My next thing, once the plot is on, is to press zoom and then the number 9. And that automatically puts me into a graph that matches my statistical data. Zoom and then the number 9. And there's my scatter plot. All right. Now, I'm going to pause the video. Why don't you sketch just a real quick view of this scatter plot, and I'll pause the video. So you should have been able to get a sketch by now. I'm going to copy and paste it in to my document so I can draw on it. And there's our scatter plot. Okay? The next thing we want to do is get our line of best fit. All right? To get to the line of best fit, your next keystroke is to press Stat. By the way, let's add some direction here in our notes. This is how we get to the line of fit. To get to the line of fit, I'm going to press Zoom, and then I need to select the Calc menu, and then number 4. So let's see how that looks on the graphing calculator. Zoom, then Calc, then 4. So we press the zoom button. Oops, I'm sorry. I said, did I tell you the zoom button or the? That's my fault. Not the zoom button first. Sorry about that. The stat button first. I knew something was wrong. Press the stat button first. Sorry about that. Stat, then calc, then number 4. So you go to the graphing calculator, press the stat button, and it brings you back to where we selected edit at the beginning. We want to move it over to the calc menu. And what I want you to notice, you remember y equals mx plus b? Do you see one up there that looks like that? Number 4. Now they use a different letter for slope than m. They use a, but it means the same thing. If you scroll down here to number 4, okay, number 4 says LINREG. That stands for linear regression. And you see the mx plus b form. Okay? So we want to press enter. And I think the newer operating system comes up looking a little bit differently. You just want to scroll down on your newer operating system, scroll down and select calculate. I don't have to do that. I can just hit enter right from here. And there is my linear regression. Now notice something. Automatically the graphing calculator gives us my slope and my y-intercept. And you need to write that down in your notes. When it gives me this screen, okay, we're used to using the letter M for slope. Well, they use the letter A. That's okay. But they still use the letter B. So, if I use y equals mx plus b to write my line of fit, I have all the information here that I need. The slope is 3.7. The slope of the line is 3.7 x plus the y-intercept, which is 12 point, and we can round it, 12.47. And guess what? Now we can graph that line through my scatter plot and see if it fits. And it's real easy. From here, on your graphing calculator, just press the y equals button and let's enter that equation. So we'll go to the graphing calculator, go to y equals, and let's enter our line of fit. 3.7x plus, what was it, 12.47. And all you have to do from that point is press the graph button. And it will automatically put my line of fit through there. All right? So, and if it doesn't go through like that, then you probably made a mistake entering your numbers in your y equals screen. All right? Now, here is the cool thing about this line of fit. All right? And I want to take my time here to talk about this. On this line of fit, which looks like this, this line, all right, which we said was y equals 3.7x plus 12.47. Okay, make sure you add the line in on your notes. That line is showing the trend in the data. Okay, this is showing, when we look at all of these, little dots in here, there and here and whatever, wasn't there a positive correlation? We've talked about the positive correlation. There's a definite positive correlation. The number of woodpeckers in this state park is going up at what we call a linear rate. Okay? The number of woodpeckers is growing in a linear fashion. in a straight line fashion. So guess what? We can make a prediction. And that's what we're going to do next. This is the final part of this problem. Let's predict how many woodpeckers will be in the park in, let's see, we're in year 2015, let's say in 2016. Now, how are we going to make that prediction? We're going to use our line of fit. We're going to use y equals 3.7x plus 12.47. We're going to use that line of fit to make the prediction. And if you remember, we were entering the year for the x values. Okay, so all of these x's along here, all of these x's, that's the year. All right? So the graphing calculator makes this easy. Didn't we start this in 1990? How many years is it from 1990 to 2016? 26 years. So what we want to look for is when x equals 26, y equals what? And the graphing calculator makes this easy. All we have to do is go to the table. So, just to refresh your memory how to do that, press second. All right. Press the second button, and then in the top right corner of your screen, you're going to press graph. So on the graphing calculator, if I press the second button and then graph, it takes me to the table. And all I have to do is scroll down to the x value that I want. We said it was going to be when x was 26. So there it is. How many woodpeckers do we think will be there if they keep growing at the same rate? About 109. Okay? So from the table, we see the answer to our question. Okay, I'll just paste that table in. Right here at year 26, we see that it looks like there's going to be about 109 woodpeckers in the park. Okay? And the line of fit helped us do that because we saw that the trend was a linear trend. It grew like a linear graph. When we went, if I look at my graph once again, we see that the growth of the woodpeckers was growing in a straight line. It was modeled by a linear equation. So we could use that equation to predict what was going to happen in the future, which makes this very useful in the real world. And we'll stop there for today.